Today we're going to blend not one, not two, but three telescopes together. They all have different focal lengths, they're all different brands, but it's going to give us one amazing image of the Crab Nebula. Welcome to SETI Astro. So a viewer reached out to me asking about combining data from his three different telescopes. He shot the Crab Nebula and wanted to combine all the data to get just the most integration as he can from it. He had an RC here, he has this ASCAR here, and a teleview there. The focal length is the longest on the ASCAR, giving the most detail for sure. On the RC, it's noisier, but you got a lot more broadness in the center structure there for brightness. And honestly, I don't think the teleview here is adding much. It is definitely the furthest as far as the shortest focal length, and definitely the least resolved. But it does kind of have that gaseous middle. So let's go about how to actually combine images like this from vastly different scopes in an accurate way. Obviously, you could just put these in Photoshop and just kind of eyeball the stars up and call it good, but that's not what this channel is about. The first obvious thing you may want to try is star alignment. That's under Process All Process, star alignment. What you're going to find is this is going to fail. They're just too different of focal lengths and distortion between them, but we can go ahead and do it. I got it set to use the teleview one as the reference. We could try to scale the ASCAR to it, and you can see it's failing. All right, so then the other thought maybe is use the ASCAR as the reference and give it a go on the teleview one. And it's failing again. So what are we to do? Well, I'll tell you what we're going to do. We're going to pretend this is a mosaic. We're going to go to Script, Mosaic, Mosaic by Coordinates. I'm going to put the three exposures or the three images in here and just execute it. Now this is going to take a bit of time. You will need to have these properly plate solved in PixInsight as well to do it this way, so be sure you went to Script, Image Analysis, Image Solver if you haven't already done that. But we're just going to let this run. When it's done running, we have our three different images now, because it just used the mosaic by coordinates to align them all. So now they're actually to the correct pixel scale and everything we're going to need. If we go ahead and zoom into the crab on one, we can go ahead and bring that view over to the next and to the next. So now we could actually see the comparison between the three telescopes too, which I think is very interesting and very revealing to me. The ASCAR by far has the most developed image out of all three of them, but that's not to say that we can't get some data out of these others, because there is data there. So let's go ahead and get these merged. Prior to the only pre-processing I did on the original images, I ran them through ADBE. That was it, just to remove the little bit of gradient that was in there. So next thing we're going to want to do is crop them all the same, just so we're not dealing with, these huge images with tons of weird black borders and all sorts of stuff. So I'm going to use the ASCAR. It's going to be the most restrictive. We can go dynamic crop. And with this, don't forget you could rotate your crop selection too. You don't need to have it just straight up and down. So we can still get, pretty much the full extent of the ASCAR image here. And we'll just go ahead and drop this onto the other ones. All right, now that we have them all to the same scale, now's the time we can go ahead and we're going to want to run star alignment. Mosaic by coordinates is good, but we really want to make sure these things are aligned with each other correctly. So we'll pull up star alignment again. We'll align them all to this ASCAR registered, and we'll just do each one. All right, the RC is done. I'm going to drop it over on the TeleView one. When star alignment's done, it'll have two new registered versions here, which is perfect because now we know they match exactly. So we can close those other ones that Mosaic by Coordinates made, and now we can see exactly like the differences. If you blink them like that, it's quite astounding, right? So based on this, the ASCAR has definitely the best stars, the best sharpness, everything else. We're going to go ahead and use that as our base, and we're going to want to pull in like some of the color data and some of the things like that from the other two, but we really don't want the stars or anything. They're much more bloated, not nearly as good as the longer focal length, larger scope. So let's go ahead and just do some pre-processing here. I'm going to go ahead and run them through Blur Exterminator. You could also use my Cosmic Clarity. Then we're going to denoise them. And then I'm going to go ahead and remove the stars from all three. If you haven't seen it before, if you right-click on the desktop area and click Image Container, you can go ahead and add the images and drag this off. And now you could actually just drag and drop processes onto this, and it'll operate on all three. It does help speed up, or at least if you want to get it going, and then you could walk away while all the AI tools are running. And if you're really fancy, you could even use a process container to put all your processes in that you want to run sequentially, and then drop the whole process container on the image container and let it all do all of it for you all together. When all that's done running, I'm going to go ahead and minimize our stars. We don't need those right now. And we can go ahead and see what the crab actually looked like in all three of them. The first thing we need to do is get them out of their linear state. So I'm going to go ahead and run statistical stretch, since these are kind of singular objects out there, right? So a 0.10 is a good starting point for things like that. I'm just going to go ahead and do a refresh the preview. And I think this is where we're going to start. We're just going to start with 0.1 for all of them. I'm going to just run it on each one, and then we'll use some curves and other things here coming up. All right, now statistical stretch is done. I mean, all three of them look really good. So it's pretty exciting to see them in this manner. You can tell that this is a much more continuum image. This is much more narrow band. And on the RC, it's kind of a combo of the two. You can see the detail on the RC is not that great at all, actually, when we get it a little processed and up here, the TeleView and the ASCAR actually do have the best detail, which is not what I was thinking when we first started processing. The TeleView one looked really bad. But that just goes to show you may have to pivot when you're in something like this, and that's what we're going to do right now. So how do we want to combine this stuff? What we may want to do is there's pretty much only color data in the RC one here. It doesn't have as much definition as the other ones, so we don't want to use this to interfere with the luminance on anything else, right? So because of that, let's go ahead and do some crazy stuff here. We're going to take the luminance out of the ASCAR. Now here's the luminance out of the ASCAR. I'm going to put it in our LRGB combination tool. I'm going to uncheck RGB. And now I'm going to go ahead and drop this over on the RC. So that's going to put all the luminance data from the ASCAR into the RC image, keeping the colored data from the RC image in it. So now we have the color data from the RC, the full ASCAR, and the full teleview. Now we need to work on both the ASCAR and the RC. I think they're the two that are kind of closest to kind of what they look like. So let's go ahead and process them to kind of bring out the best of them, and then we're going to go ahead and do some blending. Now for the RC, because of how it looked, kind of it had that green, it almost looked like a green Hubble palette, right? Just from the nature of it. I'm just going to go ahead and open Narrowband Normalization by Bill Blanchard, say it's an SHO image, and just do some tweaks. See what the image looks like. I think it kind of looks pretty good like this. I'm going to go ahead and apply it. So now we have this one, which is kind of the reds and blues. And this one over here from the ASCAR, where the reds are kind of in a different spot. So I think that's really cool. I like the teal of it. So let's continue on the crazy train here and see what result we get if we average these two. I'm going to just open up Pixel Math. I'm going to just open the editor so I don't have to type out these names. I want the average of the ASCAR and the RC registered. And I want to create a new image just to see what it looks like. So this is the image that's halfway between these two. I think this is a good balance. I think we can do a little bit more with colors and saturation coming up here. But for now, let's go ahead and kind of stick with this. So this new one here, we're going to call ASCAR RC, just so we know what it is. And I'm going to go ahead and just open curves up. I don't think we got to do a whole lot of craziness here. Let's go ahead and look at our chrominance. Let's bring that up. That should increase the, it's similar to saturation. It's a little different. Maybe we could talk about color theory later. I do like using chrominance. So I'm going to go ahead and apply that. I'm liking a lot of that. This background out here, we don't want any color in this. So let's go ahead and open up range selection. I'm just going to go ahead and do one of these numbers. So there's really, we're just going to really target the background here in a second. Control I will invert that whole thing for us. I'm going to drag the mask over. So we're going to mask out just the crab, and then Control K shows and hides the mask. I'm going to take curves, keep it on chrominance, just give it a yank down, and apply it. We want a nice neutral background. And maybe we want to see if we can't bring out those reds just a little bit. So let's just go ahead and make a red mask. Now I do have some saved scripts off to the side, but under utilities, if you have got the color mask mod, that's probably going to be your best one for doing something like this, where you're going to want the reds and yellows. We don't want any blurring. We just want the chrominance mask. Let's go ahead and run this. Let's see what kind of mask we get. We're going to want to blur this mask a little. Let's I don't know, let's see what a 10 does. Yeah, we can try that. I'm gonna apply the mask, open curves back up, go to my red one, zoom in, and yank the reds up. And you can see where they're affecting. So we'll bring the reds up and through there. Make those pop a little bit more. Get rid of that mask. And maybe we want to see the cyans. So I'm just going to drop a color mask mod save script to the side that was just cyans. And a little mask blurring as well. We'll add that mask, open curves again. And this time let's go ahead and look at the blues. And we'll bring the blues up through it like that. All right, so now this is going to be our kind of combined image of both these. So we can go ahead and minimize the RC and the ASCAR. So now we're down to the teleview, very broad kind of continuum look, and this combined very narrow band feel. And again, I think what we're going to want to do is try to match the backgrounds here, which I think they are. So let's go ahead and play around with some blending between these. So there's two scripts you could use. There's Image Blend, that's the one Adam Block has out there, and then Toolbox by Jürgen Terp. He has combined images. I'm going to go ahead and try Image Blend. We're going to do the TVRA registered, and then our ASCAR RC. Right now it's set to screen. We're not going to want screen. So let's go ahead and see if any of these are going to be good. So with a simple replacement, if you go to opacity of about 50%, that's going to be just averaging the two. So here's the average. And you could play around with this, try to find how you want to blend them. It's completely a personal taste situation. I think I'm going to leave them like that and click the green check when you're done. Now with all these things, again, just some personal taste, I'm going to go ahead and just bring up some curves. I'm probably going to bring up, because that continuum image tended to wash out some of the colors, I'm just going to bring up the chrominance some here. Let's see if we can go ahead and play with some contrast into our image. Maybe a little like that. We may want to play around with something like local histogram equalization. And you're going to want to set this so you kind of get some additional detail that you're trying to eke out with local histogram equalization. And it's really strong, so usually like between a 0.2 and a 0.3 is all the more you're really going to want to go up with it. Okay. And I mean, at this point, it's just a matter of putting our stars back in. So the ASCAR had some really nice stars. So I'm going to go ahead and just run my star stretch on them. And there is a preview on this if that's something you want. Usually the defaults work pretty good. I'm just going to go ahead and execute. And in this case, it probably wasn't bright enough for the stars, so that's no problem. Just grab your histogram and pull it to the left, and just brighten them up until you feel like they're good. Okay, I'm gonna minimize these other two, and I'm gonna go ahead and just use pixel math to screen the stars back in. So there's a couple different formulas. The one I use is the tilde version, right? The tilde, parenthesis tilde, stars times tilde starless, and that'll work. You could also do a plus b minus a times b. Same, it does the same thing. And there we go. Let's go ahead and make this a nice big image for everyone to see. There we have it. Crab Nebula from 3 different telescopes, 3 different focal lengths, all blended together. Try to give it the best of both, well, best of all 3 worlds in this case. If you guys have any more ideas like this, just email me. I mean, I love doing stuff like this. Please comment, like, and subscribe. Today we're going to blend not 1, not 2, but 3 telescopes together. They all have different focal lengths. They're all different brands. But it's going to give us one amazing image of the Crab Nebula. Welcome to SETI Astro.